No humans were harmed during the creation of this bot. This video goes over the creation of a bot that can complement images. If you want to check it out, post an image on /Complimentobot or visit complimentobot.com or tweet an image at Complimentobot. Disclaimer: none of the views of the created bot represent my own views or the views of the organizations or people that I am affiliated. This project has not been reviewed by ethics committees of any kind. I personally view this project as something in an ethical gray area. I've been browsing Reddit a lot recently. I've come across a specific type of subreddit. This type of subreddit is where humans post images of themselves and ask other humans to rate them, compliment them, or tell them if they're hot, amongst a range of other things. I've seen a lot of posts on these and I think I can do better. A lot of these compliments really suck. And some of these are just borderline cringeworthy. Time to build a bot that is better than Ellen at being nice. Now to compliment some humans. We need a few components. We need data of some sort that we can use for training. We need to train some sort of model to generate new compliments. We need something that finds new subreddit posts and compliments the human poster. A Reddit compliment post has two components, the title and the image. The post title is usually made up of a bunch of information like poster age, current mental state, recent life events, and other things. The post image is usually a picture of the post author. This is an important element for this project. A post also has a number of responses from a range of commenters. These are usually compliments about the poster's image or a reference to something in the title, and generally say something wholesome that boosts the confidence or mood of the poster. We need some method of retrieving the post data and comment responses from Reddit. To do this, I wrote a quick Python script. The script searches the Reddit and push-to-shift application programming interfaces in order to find posts from a set of subreddits. We then query Reddit again to grab all of the information. This will include the comments, images, and titles that we talked about before, as well as metadata such as number of votes and authors. Before storing the information, I did some down selection. I skipped duplicate posts, as well as skipping posts that were hidden by the moderators or marked as deleted. Posts with 2 or less comments were skipped too, as well as all posts with images smaller than 224 by 224. After all of the downloading, I had over 19,800 posts with over 160,000 comments. I had to factor in a number of constraints when deciding which model I wanted to use. For the compliment generation, I am fairly limited in terms of computer resources. I can either train models on my Nvidia GTX 1060 card or roll the dice and use Google Colab. If I want to deploy this model without massive financial costs, I need something that does not require a lot of memory. Finally, I want to do something unique that isn't a standard LSTM and CNN captioning network. Taking all of this into account, I decided to fine-tune a medium-sized GPT-2 model. I would be fine-tuning the model using prompts that contain sequences that are derived from image embeddings. This approach will need some explaining for it to all make sense. I will start by describing the embedding process. The process I am going to describe can be used with any kind of CNN that does encoding, such as an image classifier. I'm using a VGG16 model that has been trained for facial recognition using the GGG face dataset. I take off the final layer of the model, which is used for classification. The new final layer is our embedding layer, and each node in this layer now represents an abstract feature or concept that the network has learned for its trained domain. When we input images into this network, it will return a matrix of 4096 decimals. This is our embedding. In its raw form, this embedding can usually be used as input to other types of models, like an LSTM for image captioning or clustering algorithms. We are going to do a conversion. We are going to rank these decimals in order of highest to lowest, and then replace the decimal with its related node number. This should give us a sequence of integers that represent features based on how prevalent they are in the image. There's a few things we need to understand about GPT-2 in order to get our heads around our embedding representation. I'm not going to explain GPT-2 in depth, as there are hundreds of explanations out there. GPT-2 does not operate on raw text. It uses a tokenizer to convert text into tokens and then tokens into integers. These integers are passed to GPT-2 as a numeric sequence. GPT-2 has over 50,000 unique token conversions within the tokenizer. GPT-2 also has the same number of output nodes on its final layer as the number of tokens within the tokenizer. Each node represents a unique token. Now that we understand this concept, we can start considering our sequence in relation to GPT-2. If we can consider the nodes in the final layer of our CNN as unique words or tokens, we can treat them as such and can therefore assign a unique token to each node and add them to the tokenizer and add new nodes to the final layer of GPT-2 in the context of the VGG16 face model. This should mean that each of its nodes is now considered a word by GPT-2. Conceptually, this means we might have tokens that represents beards, glasses, or different eye shapes. And all this without GPT-2 having to know anything about images, which is super flexible and cool. GPT-2 makes predictions based on the order in which tokens occur in the preceding token sequence. These predictions don't always take into account every single token that is preceding. Now, in relation to our embedding, we have our sequence in descending order, where the earlier the sequence element, the more prominent it is. So in theory, the model should be able to make use of this sequence ordering, which should negate some loss of information that occurred when we converted to our representation. Now that we understand how GPT-2 will deal with our image representation, we need to establish how all of our data comes together and how we use it to fine-tune the model. To fine-tune GPT-2, we create a series of prompts. These prompts are formatted like this. We use a special token to mark the start of the embedding. This is followed by our embedding. We then have another special token to denote where the comment starts, and this is followed by the comment. The comment in this case gets tokenized to standard GPT-2 tokens. In order to avoid overwhelming GPT-2, we only use the first couple of values from our embedding, as these are the most important. The special tokens for denoting the start of embeddings and comments are added to the tokenizer and given a new node. Now that we've got the data processing pipeline explained, we can create our training data. Before we construct and train using this data, we do a few filtering steps. The first thing we do is disregard any comments that have too many words. Next, we can extract faces. We disregard images in scenarios where Dlib does not detect any faces or finds more than one face. As our post images have a single face, we extract and resize it to 224 by 222 and then run the embedding process, and then use this sequence in our prompt. Finally, we construct prompts for the valid posts that are remaining. This process creates over 150,000 prompts GPT-2 can use to learn how to complement. Fast forward many iterations and a lot of training. We now have a complement model. Now that we have a trained model, we can modify our prompt slightly in order to generate new complements. We can do so by dropping the comment that follows the comment token. If we try to generate the comment that follows the prompt, it should generate new complements. We are generating new comments by asking GPT-2 to randomly select from the top most likely tokens to follow on from the current prompt and adding it to the end of the prompt. It then selects another random token from the top likely tokens for this new longer prompt, iteratively doing so until it has generated a new complement. We can do this multiple times in order to generate multiple comments. Here are a few examples of what this model can produce. As I don't want to deal with ethics, the complements shown have been generated to non-existing humans that were generated using StyleGan2. I will only show a few examples. I will go into more depth later. Now to actually create a bot out of this. If I were to have the bot complement real people on some of these subreddits, it might do some harm to people, as many of the people on these subreddits are looking for validation from other humans. I can't guarantee the bot will be nice to them and won't say anything horrible. I therefore decided to have a dedicated subreddit or /Complimentobot where people can post an image of themselves and have it complemented by the bot to complement anyone who decides to post. Our bot checks the subreddit for new posts. If the bot finds a post it hasn't seen before, it downloads the image and creates a prompt. It then generates up to 32 compliments from the prompt and responds to the post. The post response has the compliments ordered from best to worst, as well as a general disclaimer. The compliments in the comment are not filtered in anywhere, so the disclaimer is necessary. After commenting on the post is added to a list of complemented posts, which allows us to prevent double posting. The ranking of compliments is done using a gradient boosting regressor. This model has 7 inputs. The first 4 are the sentiments values given by the Vadar sentiment intensity analyzing. The 5th is the length of the sentence. The 6th is the number of unique words. The 7th is the number of words. The model was trained on the 7 variables derived from comments in the downloaded data, with the target being the number of upvotes that a comment got. The model is scoring how likely a compliment is to be popular on Reddit based on how complex it is and the overall sentiment of the comment. Complimentobot.com is a quick website I threw together. It displays a StyleGan2 generated human on the left and the corresponding compliments on the right side. I thought it'd be cool to have something for people to play with if they did want to post an image of themselves to the subreddit. The Twitter account is a last-minute addition to the bot. It's doing the same thing as the Reddit bot, looking for new tweets and generating compliments. When it finds images with faces, it ranks its compliments in the same way as before and returns the top compliment only, along with a short disclaimer. To summarize what we had, we've created a bot that finds a post on the /Complimentobot, generates a prompt from the image, generates compliments using the prompt, ranks the compliments in terms of how well they might perform on Reddit, and responds to the poster we generated comments in ranked order. When there is nothing left to respond to on Reddit, it checks Twitter to see if it has been tweeted at with an image and responds with a compliment for the image by generating many compliments and returning the top-ranked compliment. When it's idle, it generates compliments of fake humans and stores them in a database for consumption by Complimentobot.com. These compliments are all C-ranked like the Reddit comments. This is all running on a single $20 droplet on DigitalOcean. The process is neat. 3 GB RAM to generate and post, which leaves 1 GB spare to host the website. There's a lot of analysis work that needs to be done, but I'm planning on doing that once the roast bot is also done. So before we finish up, I thought I'd do some initial analysis. I'll follow up on this with a deeper dive once the bot has complemented a few real humans. By that point, I should have a good idea about the model's generalizations and bias. I will use the process from my last video so that the fake people read some of their own compliments themselves.
You have the same smile as the Grinch.
You look like a beautiful young woman.
You look super fun to hang with, and your dog is adorable.
I think you look a little like my mother. You're gorgeous.
That jawline and smile is worth the world.
You're cuties. If I wasn't broke, I would be all over you.
Well, a lot of people have said, you look like CRISPR, but with lighter hair.
Well, that was something. It has some really creative compliments, and the long compliments are not in the training set. It really sucks at figuring out genders of people, and it often thinks a person has a feature that is not present in the image. The model also says a lot of weird things, like commenting about a person's history. I think this is due to a lack of descriptive comments. A lot of the training comment information is not about appearances, so the model is making a stretch to try and attribute some meaning to the embedding tokens. That said, I'll be interested to see how this bot performs in the wild. In the next video, I'll be looking at the other side of the coin, where the AI is roasting and insulting humans, as many communities revolve around this concept. I hope you liked this video. Hopefully you didn't get lost in the technical parts, and I hope you enjoyed some of the compliments. Don't forget to check out Complimentobot.com to see compliments the model has produced. Tweet an image at Complimentobot or post an image in or /Complimentobot in order to get complimented by the bot. Also, don't forget to subscribe, click the bell, and like.